Hi everyone, welcome to my video essay titled Exploring Pustojovsky Generative Lexicon. The objective of this video is to explain the key component of Pustojovsky Generative Lexicon and how it addresses the complexity of polysemy using dynamic semantic structure. Traditional approaches to semantics often treat word meanings as fixed, like entries in a dictionary. However, this method struggles to explain polysemy, where a single word can have multiple meanings. For instance, the word bank could mean the side of a river or a financial institution. In 1995, James Pustojovsky introduced the generative lexicon. Unlike static models, GL proposes that meaning is not stored as fixed definitions, but generated dynamically based on context. This theory reflects how language users adapt. The first major component is argument structure, which defines the roles that a word or verb can take in a sentence. For example, the verb gives involves three arguments: a giver, a give, and a receiver. This structure is both syntactic and semantic. That means it doesn't just describe grammar, it also reveals how the verb interacts with meaning. Understanding argument structure helps explain why some verbs require certain complements while others don't. Dynamic argument structure. This concept emphasizes that argument roles are not always rigid. Instead, they can shift depending on the sentence context. Take the sentence, Mary enjoyed the book. Here, book refers both to a physical object and its content. GL allows for this flexible interpretation by dynamically adjusting the argument roles as needed. This mechanism explains how we make sense of everyday semantic ambiguity. Generative lexicon also classify verb based on event structure. That is the type of situation they describe. Pustojovsky identified three categories: states like no, processes like run, and transition like open. For example, the verb open implies a change from a closed state to an open one. Understanding event structure allows us to connect verb meanings to temporal and causal relation. Qualia structure. This breakdowns a word meaning into four roles. Number 1, formal, what something is. Number 2 is constitutive, what's it made of. Number 3 is stylic, its purpose or function. And number 4 is agentive, how it came into existence. For instance, consider a knife. Formally, it's a tool. Constitutively, it's made of a blade and handle. Stylically, it's used for cutting. And agentively, it is forged or manufactured. These qualia roles offer a richer semantic representation than traditional future lists. Now, let's return to polysemy, one of the key problems generative lexicon aims to solve. Traditional models would list all senses of the book separately: the object, the content, and the event. But generative lexicon use a single lexical entry with structured component like qualia to generate all these meanings. This not only reduces redundancy but also mirror how humans understand multiple interpretations depending on context. Now we get to the questions. Now, Question number 1. Why is generative lexicon better than dictionary-style semantics? And the answer is because generative lexicon treats meaning as context-sensitive and generative rather than fixed. Instead of memorizing dozens of definitions, generative lexicon lets us derive new meanings from one flexible entry. This helps explain creative uses of language such as metaphor or extension and supports a more cognitively realistic model of how meaning works. Now, question number 2. How does generative lexicon help in natural language processing? Generative lexicon helps machine understand language by modeling contextual flexibility. In natural language processing tasks like machine translation or question answering, words often appear in ambiguous form. For instance, in The Baby Drank the Bottle, generative lexicon use semantic question to reinterpret bottle as its content. This improves computational understanding and enables artificial intelligence to handle real-life language more naturally.